Hello, welcome to lesson number 5, inscribed angles for unit 11. So today we're moving on from what we were talking about before, central angles and things like that. We're going to move on to other types of angles that are within a circle. So today we're going to talk about something called an inscribed angle. So an inscribed angle is an angle whose vertex lies on the circle. Okay, so this vertex is on the circle, like on the edge. So it could be an angle that's anywhere on the edge of the circle. So when we have an inscribed angle, it would be this angle right here. We also have something called an intercepted arc. So the intercepted arc is basically the arc that the angle creates between the rays. So here's a ray and here's another ray in a circle, and that's creating this blue arc that's happening in between those rays of the angle. All right, and there's a relationship between this intercepted arc and the inscribed angle. So let's take a look. Okay, based on the following picture, I think you could easily come up with some sort of conjecture about inscribed angles. Let me help you get there. If you know that this arc, AB, is 110 degrees, and that this angle, angle C, is 55 degrees, what do you think you can conclude? The relationship here is that if I take the arc and I divide it by 2, that gives me the measure of the inscribed angle. So central angles are actually equal to the angle that it creates, whereas the inscribed angle, imagine taking this and like pinching it back, the angle is not going to be the same, right? It's going to get smaller if it has the exact same arc. So that's why it's not the same measure, it's actually half the measure of the arc. So here is our big arc at 280 degrees. If I divide that by 2, I get my angle at 140 degrees. So that's our conjecture. Now I drew this picture, so if you want to pause the video and draw this picture as well, you can. Go ahead and pause now. Hopefully you've copied down this picture, and let's figure out the measure of angle ABC. That's this angle, okay, is going to be 1/2 of the measure of the intercepted arc, which is arc AC. Okay, so the angle is 1/2 of the arc. That is the relationship. So here is an example. If I know that this angle is 40 degrees, okay, then find the measure of arc AC. Now remember, if it says measure, I'm not looking for an arc length, I am looking for a degree, a portion of the circle. So this is going to be 80 degrees. So you multiply the angle times 2 to get the arc. Now if I'm going backwards and I was given the arc, to go back to the angle, you divide by 2. So it just depends which one you're given. If I'm given the arc, I divide. If I'm given the angle, I multiply by 2. Okay, so with that in mind, let's do some examples. It says find the measure of x and y. Okay, well, first let's look at angle x right here. So if this arc right here is 55 degrees, to get the angle, I have to divide that by 2. So in my calculator, I will do 55 divided by 2, which is 27.5. Okay, now let's take a look at arc y. Now, if you think about it, this entire arc from I to j is a semicircle, 180 degrees. So to find that arc for y, I'm going to take 180 and I am going to subtract out this small arc, 55. So 180 minus 55 gives me 125 degrees, and that's y. Okay, moving on to the second example. Now this one's interesting because if I trace, it's kind of hard to see it because both of these angles, they're in two different spots on the circle, but they open up to the exact same arc. They both open up to this 120-degree arc. So x is going to be half of that. 120 divided by 2 is 60. But what's interesting is that even though y's vertex is in a different location, it's opening to the exact same arc. So even though they're in a different location, those are going to be the same measure, which leads us to a theorem. So the first theorem is what we just kind of discovered. If I have two inscribed angles that intercept the same arc, then they're congruent. It makes sense. So just like in this last example, this angle was 60 degrees. It opens up to an arc. And if this angle opens up to the exact same arc, then it also has to be 60 degrees. There's no other way around it, okay? All right, so angle X is going to be congruent to angle Y in this scenario. The second theorem is that if an inscribed angle intercepts a diameter, then it's a right angle. This makes sense. If this angle right here is opening up and the arc it opens up to is the diameter, then that means that this is going to be 180 degrees, and if I divide that by 2, I get 90. And finally, a quadrilateral can only be an inscribed angle if and only if, that's what the if with two F's means, if and only if the opposite angles are supplementary. So I kind of drew this picture. Again, if you want to pause the video and copy this down, you can. So the green arrows are indicating that angles F and D, those are opposite angles. Those are going to be supplementary. And likewise, angles E and G are also going to be supplementary. Using those theorems, let's do a couple examples. So for this first one, I know that the opposite angles, so angle P and angle, this one, it's not labeled, those are going to be supplementary. So if I know that this one's 90 degrees, then I also know that P has to be 90 degrees. Because they have to add to 180. They're supplementary. All right, also supplementary will be these two. Now this one's a little bit harder. Let's take 180, let's subtract 58, and that will give me angle Q. 180 minus 58 is 122 degrees, and that's going to be angle Q. Moving on to this one. Okay, so what I notice here is that angle Z is opening up to this 72-degree arc, okay? So that means that Z is going to be 72 divided by 2 is 36. Oops. Okay, well, take a look at angle Y. Y opens to the exact same arc. Even though it's on a different location, it's opening to the same arc. So Y and Z are going to be congruent. But then what about X? Well, X is not congruent. However, we do know that this angle that I'm highlighting in red opens up to this arc, which is 112. So if I take 112, I divide that by 2, it's going to be 56. And that's your X. Okay. Okay, a couple more theorems and then we'll be done. So this last theorem, and then we just have some problems to do, is an interesting one. If I have a tangent line here, okay, and then a chord that kind of takes that tangent and connects that point of tangency to another point, it creates these two angles. So I have this angle 2 right here, and then I also have this angle 1, which these angles are not totally inside the circles. However, there's still a relationship between the arcs that it creates. So I highlighted the orange arc right here. So that angle 1 creates that arc, and there is also an inscribed relationship. So if that arc is 100, then the measure of angle 1 will be 50. Okay, and then if this green arc that angle 2 kind of creates is 260, then angle 2 will be half of that, 130. Okay, so the measure of each angle formed is 1/2 the measure of its arc. It's still the same theorem, it just looks a little bit different because these angles are not totally inside the circles. But now that we know that, let's do our last few examples for this lesson. So this is a central angle at 132. Now remember, central angles are congruent or the same measure as the intercepted arc. So this arc is going to be 132 degrees. It's the same as the central angle. However, this angle is going to be half of that measure. So we're going to take 132, we're going to divide that by 2, and I always like to show my work in my calculator, even though a lot of us can do this in our heads. Okay, but that's all that's happening, is I'm just dividing by 2. I'm using the fact that central angle is equal to the intercepted arc. The inscribed angle is half of that arc. Okay, now let's see the next one. This is asking, I always like to highlight what it's asking for, GHI. So it's asking, let's use a different color, GHI. It's asking for this angle right here, which is going to go with this arc. And it's also asking for this section, GH. Okay, well, I do know that both of these together are going to add to 180, so all I have to do is find one of them, and I can do that pretty easily because I know that this is 94 degrees, so that means that these are vertical angles, so this angle is 94 degrees. Now that's a central angle that's opening up. If you're having a hard time seeing what it opens up to, trace it. This and this opens up to G and H, which means arc GH is 94 degrees. It's a central angle, so it's the same. Okay, now if that's 94 degrees, I can easily find this orange chunk because remember, these have to add to 180. So to find this orange arc, GI, I'm going to subtract 180 minus 94, and that's 86 degrees, but be careful. That's just that arc. So this arc is 86 degrees. Now, it's also asking for the measure of GHI, which I'm going to highlight in pink, or I'm going to trace in pink. GHI opens up to this 86 degree angle, but it's an inscribed, so I have to divide by 2, which makes that 43 degrees. Okay, number 3 uses our theorem that is opposite angles here are going to be supplementary. So 2x plus 100, and if I add those together, they have to add to 180. So x is going to be 40. And for this one, we have y plus 87 equals 180. I think we can all do this in our head. I just like to show my work. It is going to be 93 for y. So you guys can see what I'm typing into the calculator so that there's no confusion at all. Now, this one, last but not least, we have this angle is 3x. Now, I personally like to kind of trace it to see what arc it's opening to, if it's an inscribed angle, which it is because it's on the edge. So we're opening this 3x angle to that yellow arc. But if you take a look here, this angle is opening to the same exact arc. So what does that mean about them? It means they're congruent. Okay, so that's the theorem. We are just going to set 3x equal to 2x plus 13. Subtract that 2x over. So 1x, or just x, equals 13. And that's the lesson. So lots of theorems to think about. Biggest takeaway is that the inscribed angle, which is on the edge of the circle, is half of the arc that it intercepts. If I give you the angle to get the arc, you would then do the opposite of that. You would multiply by 2. Then we learned some theorems about, inscribed angles opening to the same arc are congruent. The opposite angles in a quadrilateral that's inscribed are supplementary. We talked about central angles again, and I think that's about it, guys. The right angle theorem as well with our diameter. So that's everything. Feel free to pause, go back, relook about any of these, and we will go over it again tomorrow.